Hey YouTube, Fecal Junk here. I'm here to start my next tutorial on hacks. Um, so what I wanted to cover in this one is keyboard inputs because it's kind of the next, it's like I think it's probably one of the more important things to start out with because you like if you're starting out, you want to see something happen on the screen. Yeah, I can make a tutorial where you see like a box go flying across the screen and that's it. But I think you guys would find a lot more interesting if you could finish your second tutorial and you're already got something where you push a button on the keyboard and you're seeing something fly around the screen, which just totally can hook you. I mean, right off the bat, it's pretty cool. So let's get right into it. Let me close this. Get my tablet out of the way. Um, Close that and close that. Okay, so over here, don't worry about this. I'm just gonna actually cut that out, and you'll only see this code. So we're gonna zoom in, Shazam, and if you look over here, this is the code I left you guys off with last time. It's collapsed, but it's the same code. So we're not going to be doing anything with the special player class because there's not a big reason to right now. We're going to be focusing on this stuff up here. Zoom. Um, so yeah, we got our update here, and the way the update works. Oh, don't need this in here yet. The way the update works, it's a an event. Uh, it's really similar to how the Flash events work. It's actually like exactly the same. OpenFL just kind of rewrote them or repurposed them somehow. I'm not exactly sure. But anyways, so you start off with add event listener. Add event listener is actually calling a hmm, it's actually more like saying uh this dot add event listener. Even though this I don't think is a keyword in Haxe, but it's pretty much referring to this instance of this class right here. So of main, it's saying main add a listener to yourself called or add this event listener to yourself and assign it to this function. So that's what's happening. You don't want the this in there. That's just for you guys to know. Um, so enter frame is an event listener that fires. It pretty much this is like what starts your game loop. So as soon as the game first enters a frame, it'll start firing this function, and then it just continues until you tell it otherwise. I think it's actually just saying as the next frame starts, or as we're entering into the next rendered frame, run the update function again. That's what's essentially going on. And as you can see, what happens right now is it grabs the mouse position and, or yeah, it grabs the mouse position and it gives that to the player. And then the player is able, then the body of the player is turned. I actually changed, object to player. So if you guys want to go ahead and change that, otherwise I'll post this code to Pastebin again, and then you can re-download it so you don't have to do it. Um, so anyways, now you kind of get a basic understanding of how the update loop works. You could actually see that in my previous tutorial. I'm gonna have to rename it, but it's the one that's describing the flow of video of how most games work. So yeah, this is just the central hub for everything as of right now. I mean, it's gonna change later, but as of like for right now, we're just working with it, and we're gonna do little things, and we're gonna abstract them later. So let's get something moving on the screen. So a lot of our keyboard events typically you would use a event listener to see what's going on. We're gonna first start off by adding an event listener to the stage to listen for keyboard events, which would be you pressing or releasing keys. So we're gonna start off up here. We're gonna do import open fl dot event keyboard events. Or no, it's dot events dot keyboard event. it'll make a library available for us to use, which contains the keyboard events, which is what we need for listening to the keyboard. Stage. Now this is telling us stage is part of the base class of sprite, I think. Yeah, either way, you got to refer to stage because that's where your keyboard events are going to be happening, because you'll have the window, the window will be on your focus, so which is the stage. So you got to add the event listener to the stage because that's where it's going to happen. So add event listener. So yeah, if you're running into issues like your event listener is not running for some reason, you might have forgot to add stage. Just, yeah, something to check in case you need to. Keyboard event dot key. This is all caps. Key underscore down. So this is when your key actually hits, when it's activated, not when it's released. And we're going to make a function called on key down. Semicolon. I'm going to go down here. Public. There we go. Okay, so now we got this function, and you might be wondering what this is for. Yeah, so this is a required parameter for handling the keyboard events, because it allows us to actually see what's being pressed. And make sure you make that a void, because we're not returning anything. You might be able to leave that blank, but it's better to be explicit sometimes. So let's do a trace real quick, and we're going to see what is getting printed out on our keyboard. So e dot key code, and that should do it. Yep, so you can see over there. Okay, so I'm going to hit W A S D. So these are the keys we need to do WASD keys. So I'm going to close that game. And in some commented code, I'm going to paste this in here. Hey, stop it. There we go. In case you're wondering how I did this multi-line select thing, you can use your middle mouse button. It's kind of cool. Hey, stop it. So there. Yeah, this one's W A S D. So now we know what keys we got to look for so we can do stuff to our player object. So let's start off. If key code is equal to 87, we're going to make it so our player's Y position is moved 10 units. I think it's a measurement of pixels in Haxe. I'm not exactly sure. It's probably, yeah, I'm pretty sure it's pixels. Dot Y, we're going to do minus equal 10, because in Haxe, negative on the y-axis is going to the top of the screen, or positive y is going to the bottom, because 0, 0 is starts in the top left corner. So that's how that works. So yeah, your y is flipped, but the x is normal, because left x is negative and right x is positive. So just in case you guys are working on something and you're wondering why your up is down, your down is up, int should be bool. Oh yeah, that's right. You need a double equals. My bad. Control Enter. So now if I press W, we go up. But the only problem with this is we go only one way. We go off the screen. And every single time I want to move, I have to press the key, which is fine if you're doing like maybe one of those like turn-based dungeon games, you know, where every time you press a key, that counts as a move, and then everybody else moves. But that's not what we're going for, because we want to do a spaceship or we want to do asteroids, where if you hold the key down, that'll count as you moving. It's gonna be a consistent movement of acceleration. So we're gonna have to do something different. We can start off by listening for the rest of the keys. So we're just gonna copy and paste this because I am super lazy. We're gonna do 65, 83, and 68. And we gotta remember that this one is D, this one is S, this one is A, and this one is W. Yeah, if we wanted to, we can make these all like, so this one's gonna be X, and that one's gonna be -10, this one's gonna be Y, and this one's gonna be positive, and this one's gonna be X, and this one's gonna be positive equals. And in case you didn't know, the positive equals is a shortcut, pretty much saying, like, it would be the equivalent of saying player.x plus 10. That's essentially what it's saying, except I'm not writing in the player x, I'm just doing plus equals, so it's implicitly saying I want to add 10 to x. That's what plus equals and minus equals and multiplication equals and division equals does. There's probably some more of those that I'm forgetting, but you guys can look into that if you want to. Yeah, and double equals, that's always a Boolean operation. So now we can test it. And now I'm holding, oh hey, it does go. Okay, so yeah, you can hold it down, but you can see it's jumpy, and as soon as I let go, it's done. So yeah, we can move it around, which is nice. And also it has that half-second lag, because it's acting like a, it's like when you, let's open Notepad, I'll show you. So it's taken off that effect where, you know, you hold the key down, and it has that half-second delay, and then it goes. That's what's happening. That's why I'm having this split-second delay of going and stopping, which isn't what we want. We want a really fluid movement, and we also want to carry momentum, which is going to require some vector math and some physics math. And also, we can't go up, like up and down at an angle. I can only hold one key at a time. These are both pretty limiting. Yeah, so we'll have to play with it. So instead of, this is typically a bad idea. Just because you don't ever want to directly work with the objects, because, okay, say I got like 20 different players, you know, am I going to have 20 different, am I going to have 20 lines of code for each of these if statements? You know, dealing with these players individually, how they move. No, you don't want that. That's a really bad way of doing it. This is just for an example, and show you how the keyboard events work. So next, I'm going to take a pause. I'm going to write some code, and I'm going to come back, and I'm going to show you what I came up with for the how we're actually going to move the object around the screen. So if you want to, you can pause the video and maybe try to figure out yourself. But yeah, I'll be right back with the continuation. Okay, you guys, so I'm back. Yeah, as you can tell, it took me like an hour. I'm a pretty slow programmer most of the time, so that's why I decided to pause the video so you guys don't have to watch me ramble and try to figure out the best possible way to do this and also be something that's digestible. Not that I could probably really swing too far above your guys' heads, but yeah, it's just a conveniency thing for you guys, so I can get right into it and you don't have to watch me stumble. So let's take a look. Now, the issue, yeah, I cleared out the key events because we're going to be completely redoing those anyways. So what we want is a fluid movement, and we want the ship to be able to fly around really fast, but then we don't want it slowing down, or at least if it is slowing down, we want to be able to control how fast we want it to slow down, thus, which would be a force like drag. So let me explain how we're going to be controlling our ship, because you may be thinking, well, we're just going to be adding and subtracting to the XY coordinates directly. This can be a good idea for some games, but for like 90% of the time, you never want to control, well, maybe not 90% of the time. I mean, it depends on what you're doing, but a lot of the times you're not going to want to control the player's position directly. It's just a bad idea, because then you're going to get stuff like, because let's say you're holding the W key. Yeah, you're going, you let go, stop. You don't have any slide, you have nothing. It's just, this is called a, I think, what is that? Oopsie. Okay, I'm back, sorry. Yeah, I'm using Fraps, and if I have my second monitor open, Fraps freaks out, and I forgot to shut it off, so I'm back. Anyways, yeah, so I believe it's called inverse kinematics, is when you're directly controlling an object's position, which sometimes is a good idea, but a lot of times it's not, because instead of directly controlling where it's going, you'd want to run it through a physics engine. So you'd want to apply acceleration, and then there'd be other forces working against you, thus limiting your movement. That's a way of doing it, which is kind of the way we're going to be doing it. It's not going to be through a physics engine, but it's going to be sort of like a just a really cheap knockoff of a physics engine. And I'm talking really, really cheap. So what we're going to be doing, okay, so we have our object, right? I need to do a better circle than that. There we go. Okay, so we have our object, and our object speed is 0 right now. So we want to make it so the speed is not 0. So how do we do that? Well, we're going to apply a force to it, acceleration. Our force is going to be 1 pixel per frame. And if you don't know what acceleration is, it's distance over time squared, which essentially is saying how much faster you're going per unit of time. So you'd have speed, which is distance over time. This would be controlling how much faster you're going per second. So yeah, if I'm going 60 miles an hour, right? And my speed isn't going up or down, I have an acceleration of 0. Now if if I had an acceleration of 60 miles per hour, which would be insane, that'd probably kill you, that means the next second, so right here, I'm at 60 miles an hour. At this second, if I had a 60 mile per hour acceleration, I would also be at 120 miles per hour. That's how acceleration works. It's not extremely important you understand what's going on, but you need a gist of what's going on. So we're going to be actually controlling the position through acceleration, which is what's going to give us that nice fluid movement that we're looking for, and that space feel. And then we can also implement drag really easily without having to do any fancy calculations. So let's hop right into it. So first of all, we got to get our keyboard, we got to find a better way of doing our keyboard inputs, which I came up with a way I've been doing some reading for you guys. And one way I really like doing it is using a dictionary, but in Haxe, it's called a map. So we're going to make a map called keys. I'm going to explain what a map is real quick. So a map is a collection of objects that have a key value and the actual value. Our key value is going to be a string. It could be anything actually, but we're going to make it a string just so you guys can see it better. And the other one's going to be a Boolean. Now, you're going to see here in a second what I'm trying to go for. If I can find the angle brackets. Jeez. Okay, so our first one is going to be W. which its default value is going to be false. And you can already see what I'm doing. It's literally a dictionary. So the computer would say, so yeah, if I wanted to look up W, I'd go keys W. And then if I put a trace around that, oops, it would print out false because that's W's value. So now we're going to add in the other keys real quick. And I'm sure this equals greater than, it's a fancier meaning than what I'm doing, but just take it as you're setting its the value for the key. That's all you need to know. And that's going to be false as well. So we got that. Now you're got to be wondering, okay, so how are we going to set these? And you may even already know. So I mean, you could probably skip ahead if you want, if you already know what's going on. But for those of you who don't know what's going on, let's start off in the on key down, because when you press the key down, that's when that value should be true. So let's come up with an if statement. If e.keycode is equal to 87, which is W. We're going to make it nice and compressed so it's easy to read. Keys W, and we're going to go equal true. Oh wait, lowercase t. And there. So now whenever I press the W key, this is going to get set to true. This key's value is going to get set to true. So now we're going to do that for our other ones real quick. Oops. W, A, S, and these are case sensitive, so just a heads up. Now, if you wanted to, a more efficient way of doing this, instead of doing a string of WASD, you could actually do, I gotta get the other values. You could, instead of doing string bool, you could do int bool, and instead of W, do 87, A would be 65, S would be 83, and D would be 68. That's one way of doing it, but I'm doing it this way so it's easier for you guys to read. You could also do an enumeration with values assigned to the enumerations, and then it would still say W, but it would actually have the value of 87. So if you wanted to go the extra mile and make it look nice and also more functional, I'd say go for it, because enumerations are pretty nifty most of the time and something you should know. Yeah, I'm just going to copy and paste that. Middle mouse click, drag, and now we can, oh yeah. That's one reason I really like Sublime. Some of the other text editors do that, but I don't know, Sublime does it really well. So yeah, now we got all these values being assigned. Oh yeah, and we have to put these in here because we have to reset them to false when you let go of the key. Otherwise, the program's just going to assume that your key is being constantly held down, which we don't want. Now, what I'm about to do isn't the most optimal way to tell objects that a key is being pressed. This is just a simple way of doing it so that you guys can build off of it. So we're going to add a function to special player class, and it's going to go public function, and let's do I want to say add acceleration, but we should do handle input, and our input's going to be, let's do KS for key states, and we're just going to, and that has to be a type of map string bool, and yeah, so that's all ready to go. Now this is the important part. This is where we're actually going to start doing some math. Oh, right after I add a couple more variables, we're going to need 2 more variables of my vector 2D object. because you can actually represent the speed you're keeping track of and the acceleration you're keeping track of as vectors. Because if you think about it, let's go back to MS Paint. Best program ever. Let's get rid of that. Hey, come back. Okay, so yeah, let's say our speed is we're going up on the y-axis at 5 pixels per frame, and actually, okay, let's say we're going right on the x-axis at 5 pixels per frame, and we're going up 2 pixels per frame. So it's going to be, so we're here. The next frame, we're going to be about right here. So we can just draw a line. Yeah. And that's essentially what it looks like. And so as long as nothing changes our speed, we're going to go to the right 5 and up 2. So that's where we're going to wind up again. And it's, yeah, so that's essentially a vector right there. You got your starting position and you got where it's going to. Well, yeah, so this is where it's going to. So 5 comma 2, that would be an accurate representation of our speed. Not necessarily our position. Our position's being held lower in the sprite base class in the X and Y parameters. Which, yeah, that's not really important right now, but just so you know. Okay, so let's say we press the W key so because we want to go up. Or no, let's press the A key because we're going to the right way too fast. We got to slow this thing down. So now, what would an acceleration vector look like? Well, it looks exactly like a speed vector. So now instead of, and this vector can be in any direction, but for right now, this is what it is. It's going to be, let me get my pencil back, -1, comma 0. That's our acceleration vector right now. Why is my paint so small? There we go. So yeah, that's our acceleration. Now, how do we take our acceleration and apply it to our speed? Well, it's actually a lot simpler than it sounds. You literally take 5 and add it to -1, and you take 2 and you add it to 0. So now and what's actually happening, let me get a different color. I'm drawing in red now. That's gonna be this new drawing, and it's gonna show us what's happening to our speeds. So this is the vector. This is -1, comma 0, right? And the easiest way you can add vectors, like visually, is you take the vector you got, and then you take the vector you want, put it on the end of the new vector, or the old vector, and then draw a line. Green is going to be our final vector. This is what our speed is now. So this is our new vector, which is now going to be 4, comma 2. Cool stuff, right? So that's our new speed. And if we keep holding down that key, the next frame, it's going to add -1 to our speed again. So then we'll be at 3, comma 2, 2, comma 2, 1, comma 2, 0, comma 2, and then we're stopped, but we're still going up. So you'd have to press down and add to that acceleration. Or you'd have to apply acceleration in the down direction. So if that makes sense, great. If it doesn't, I'll try to find some links for you guys to understand vector math a little bit better. It's a really simple concept once you get it, but before that it can be a bit confusing. I took physics, so it makes sense to me, but if it's eluding you right now, don't worry about it too much. Just kind of follow along and you should do fine. Okay, so we're going to rename these speed, because it's got to go fast. And this one's going to be Excel, because I don't feel like spelling acceleration. And now remember, our keys are not going to directly affect speed. We're only going to be affecting acceleration. So let's start off with, let me go to my cheat sheet. Okay. If key stay. Oh wait, die. KS W is equal to true, then do stuff. That's essentially what's happening right there. I'm gonna flatten this out so then it's easier to cut and paste. Yeah. Boop, boop, boop. Okay, so W A S D. And now acceleration. Now we're going to be adding to the accelerations vector, which I actually went ahead to my vector class and I added a couple of functions that we're going to need later on. Multiply vector we don't need right now. Yeah, so vector, add vector, it takes in a vector and it takes the current vector you're in and adds the one you put in. I also added these constant vectors. So up, yeah, there's -1, down 1, left, -1, right, +1. So now we have an easy way of keeping constants in our program. So we're going to take acceleration. We're going to do dot add vector, which is using this function down here. And we're going to plop in vector 2D dot up. So that's just a nice convenient way of dealing with that, so it doesn't look so ugly when you're trying to read through it. You know what's going on right now because it explicitly says you're adding to the acceleration vector with vector up, and you know up is a constant of -1 in the y direction. So let's do that for the rest of them. I'm just going to be lazy again, and we're going to cut and paste, or copy and paste, not cut. And we're going to do a control. Fine, be that way. Don't even care. Oh boy. Control V. Delete. Delete. Okay. And now this is A, which is going to be left. And this is going to be down. Dot right. There. So yeah, now you can tell what's happening to acceleration and when it's happening, like when these things are happening to it. So yeah, now we're adding to our acceleration, but nothing's really happening to it. There's also one more problem with this. I'll show you in a second. Also, we should instantiate our vectors with default default parameters. Some people say you shouldn't do this. I honestly don't really care too much right now, because yeah, sometimes you shouldn't be doing this, because if you instantiate objects outside of the new function, there's a chance that you could break your program because you didn't account for something. But this part is so dead simple that nothing could go wrong, at least with these two. If you see right here, I'm actually not doing that, but I am using it somewhere else. Come here. Yeah, if look at it's null, then whatever. And if I did set a new, it would assume it's not null. It would assume that it has a value, and it would run through this code, which I don't want it to. So yeah, it's just all about what situation you're in. In this situation, we're going to do new vector 2D, which is going to assign it a blank value of 0. I'm not going to explain these. You guys can read up on it if you want to. It's a way of overloading the constructor, which you can't technically do in Haxe. For some reason, you can't do overloading functions. I'm not quite sure why. It's just a limitation of the language. So yeah, we're adding to our acceleration, but the problem right now is we're adding to our acceleration, So if you think about it, every single frame, and if I'm holding up, right, I'm adding 1 pixel, or I'm adding 1 integer to our up vector for acceleration. So after 2 frames, we're at 2, 3 frames, 3, and but then our acceleration's adding to our speed later on. That we'll get that going. That's gonna add up really, really fast. I'll leave it like this so you guys can see what happens because it's kind of funny. I didn't think about this one time when I was doing that, and the thing just goes crazy, and you're like, "What just happened?" And I'll show you guys what happens. It's kind of cool. So next, we're going to be adding to speed dot add vector, and now we're just going to add the accel vector. Tab that in, make it look nice. Hey, stop it. And then a way we can apply a drag to our object is by multiply vector, and we'll do times 0.99. So this means every single frame, it's going to be taking away 1% of our total speed in both directions, which is roughly taking away 1% speed every single time. That's, yeah, I don't know. I don't really care right now, but that's essentially what's happening. So we're going to do this dot x, and we're going to finally be adjusting our speed based on our acceleration, plus equals accel dot x, capital X, because that's what's in the vector 2D. Yeah, Sublime doesn't have the best IntelliSense, but it's good enough most of the time. If you want better IntelliSense, you might want to look into Flash Develop. That's a pretty decent one, except I always have, I don't know, I kind of got sick of it. Just little tiny things kept annoying me about it. Okay, so, yeah, now we can run it, and you guys can watch my ship go careening out of control. I'm apparently missing a semicolon somewhere. 35. Let's open this up. Control Enter. Okay, so here we go. Oh, no go. Something's not working. Let's take a look. Handle input. Blah, blah, blah. Oh, wait. No, we should be doing speed. My bad. Speed. Give me all that speed. Still not working. What is going on here? Handle in, oh. Yeah, it'd help if we actually called the function. Dot handle input. Nose is itchy. And we're gonna bring in keys. Semicolon. I'm gonna get rid of this trace statement because we don't need it. Now it might happen kind of quick. Soup. See how fast that went? Yeah, it probably already went back up. I was holding W. Oh, there it goes. Yeah, so you can tell it takes off really, really fast. Like, yeah, it's because the acceleration is going up, and so is the speed. So it's almost as if, I'm pretty sure that's an exponential rate for velocity. Anyways, how are we going to fix that? Well, one way of fixing it is making it so we just reset the acceleration to 0 every single time. Because we don't technically need a constant acceleration all the time. Because we shouldn't. It's not normal for your acceleration to be constantly going up. If you're in a car and you're on the highway and you're reaching, as you approach, like you're taking the entrance ramp, you approach 70 miles an hour, yeah, you'll start off with an acceleration of maybe, I don't even know what like a normal acceleration is for a car, let's say 2 meters per second. So that means at 1 second you're at 60 miles an hour, and the next second you're at 62 miles per hour. I'd say that's not a horrible acceleration. but it could be. Yeah, it probably is. But anyways, as you approach your target speed, your acceleration would be going down. So you'd slowly be approaching, or actually kind of quickly, you'd be approaching 0. But you'd start off at a higher number, such as like 1 or 2 meters per second. That's like when you're going down the ramp. And then once you actually get on the highway and you're doing 70, you'd finally be at 0 for your acceleration, 0 meters per second squared. So how about we just reset the vector 2D back to 0, or every single time we go to handle the inputs. So then if there's no new inputs, the acceleration is going to be 0 and you'll just be drifting through space. Class vector 2D cannot be called. Probably should put a new in there. And look at that. Way more easy to control. So yeah, I'm just using the WASD keys. And we're just going in circles. And I still got the look at constraint thing going. So maybe we'll leave it that way. And that'll be how you control where your ship's shooting. That'd be a pretty cool control. I was thinking about making it some different stuff. Like we can make it so like if you press W, then it would just drive towards your mouse, you know? Because it's kind of confusing this way, if you ask me. But as you can see, we slowly slow down. Slowly slow down. But yeah, that's because I put in that 0.99. See, if I left that at 1, which you could just not put in because 1 times anything is, 0. Or, I'm an idiot. It's 1 times anything is anything that you originally put into it. Don't make fun of me. I'm tired. It's like 11:30 almost. 49, it's mad because I'm missing a semicolon? Where? 74. Delete. 74. Oh, I got an extra parentheses in here. Okay, there we go. Okay, so yeah, here we are. And watch, it just goes. I'm not touching it. It doesn't slow down. Doesn't speed up. Stop. Yeah, it just goes. But it doesn't slow down at all. Which is, if that's what you want, perfect. If it's not, yeah, you'd want to do that multiplication thing. Right? Nah. So, you can do as small of a number as you want. And have really little drag. And you can see how, yeah, that's going to take forever. But it will slow down eventually. Another thing you want to do, possibly, is figure out a way to force a speed limit. That's one thing you guys should be able to figure out how to do with this information. I can post some hints later on if you guys want them. Otherwise, that's pretty bad. Well, there's one more thing. If you want to be able to adjust your acceleration, but you still want to use this up, down, left, right. Actually, I gotta make one change. Oh yeah, so so vector, multiply vector, it returns itself. You don't have to do anything with it, but it does return itself, which is kind of nice, because then I can go up here, multiply vector, and now I can say, okay, I want the acceleration for going up 80% of what it was, so times 0.8, and that'll make it so when I press the up key, it's going to give us 80% of what we were doing before. So up, you can see that's slower. Yeah, I can't even keep up with D. Yeah, it's gone. I can't get it back. It's way down there. But yeah, that's one way of changing your acceleration if you still want to use this up, down, left, right thing I got going here. But that's pretty much it for moving a character around with this kind of motion. Yeah. The next tutorial, I think I might do a animation or something like that, or we could maybe look into sprite sheets. Yeah, so things I want to do eventually, it's going to be sprite sheets, so we can do animations. I want to do a better, like a object pooling. So it's a way of handling sprites moving around on the screen, because right now this isn't a good way of dealing with a ton of objects, because you don't want, like, you know, I mean, for each asteroid, you're not going to have a variable for it. We're going to have something, we're going to make a new class somewhere, and it's going to handle all of our asteroids moving around. It's going to be part of the update loop still, but it's going to handle how the asteroids are moving around, and also we need one that holds, it needs to handle all the bullets that are flying around on the screen. And if you have them all coming from the same class, you can have them all running in the same handler. We'll get to that later. I'd like to do particles as well. I might look into particle systems for Haxe. I don't know which one, I don't know ones that exist, but it'd be kind of cool to look into that and see if we could find something that's relevant, because I could show you guys how to do a simple particle system that doesn't look great, but at least you know how to do it, you know? We could also look into doing like a scoreboard UI system, something like that. That'd be something cool to do. I gotta write these down, then I can remember. But anyways, I'm gonna end it here, guys. Thank you for watching. Please comment, rate, subscribe. I'll try to come out with another video in a week or so. Hopefully I don't have too much homework. Alright, I'll catch you guys later. Have a good one.